Richard Preston is living with an incurable brain cancer called glioblastoma. So Richard, you were diagnosed 5 years ago.
Yep.
And what did they tell you at the time?
Bad news, you've got terminal brain cancer, it's malignant and it could grow back at any time. So within 5 days of the optician saying there's something dodgy at the back of your left eye, I was in the operation room having a 6-hour operation on my head.
Although brain cancers are rare, they disproportionately affect young people and are more often fatal, so their impact can be greater. So why are brain tumours so hard to treat?
The brain is insulated from the rest of the world by something we call the blood-brain barrier. And so actually most of the chemotherapy drugs that we give that might work for breast or lung or colorectal cancer just don't get into the brain.
Professor Hajitou has been working for 12 years on a cancer treatment using bacteriophage therapy. Bacteriophages are the most abundant and diverse microbes found in the body, but the property that makes them of special interest is that they can cross the blood-brain barrier. A bacteriophage, or simply phage, is a kind of virus that only infects bacteria. Thousands of varieties exist, but each variety infects only one or a few species. The phage punctures the surface of bacteria, injecting it with its own genetic material. The bacterial DNA is then modified to manufacture more copies of the phage, which eventually kills the bacteria. So how long before you see any changes to the cancer cells once the phages have been added?
With the first generation of viruses we had, it could take up to 4 or 5 days, but now with the superior, we have better viruses, it could take 2 days to start seeing the death in cancer cells.
Professor Hajitou and his team have genetically modified a type of phage, known as M13, to recognise receptors found exclusively on the surface of cancer cells instead of bacterial cells. They also edited the virus's genetic material to include a therapeutic gene which activates when injected, producing a protein that destroys the cell.
Surgery by itself is not enough to remove the whole tumors. It has to be combined with other therapeutic approaches like chemotherapy, radiation therapy, in order to destroy the remaining cells. But in these cells, you find what we call cancer stem cells, which are resistant to chemo and radiation therapy, from which the tumors grow back and lead to death of the patient. This is where our phage comes with this advantage, because we showed that our phage can find these cancer stem cells and destroy them.
So how confident are you that phage therapy can cure glioblastoma?
To be frank, only clinical trials in human with glioblastoma will prove that. But we are optimistic. We hope it will happen. We have to live in hope.
Clinical trials may begin in the UK within the next 3 to 5 years, but they could start even earlier in other countries.